Hi, I'm Alejandro Hoyos, and I had the great fortune to meet the amazing engineers who work in the Raptor Lake processor that will be known as the 13th Gen processor. I'll be talking to them in the different subjects of design, validation, and how these come together through product management. But before we talk to the engineers, here's what you need to know about these new processors. The code name is Raptor Lake, and the processor brings more cores and higher clocks than the previous generation. The first ones to hit the market will be the 3-unlock K-series desktop CPUs, which are led by the Core i9-13900K with a frequency up to 5.8 GHz. And there's more to come, with additional desktop and mobile models. Tell me about your work on Raptor Lake.
My work has begun even prior, of course, to Raptor Lake. I've been working on the previous generation, which was Alder Lake. From there, I've taken some of my features to Raptor Lake and enhancing them. Sometimes you think of new features or improving your own, but there's not enough time to make it.
So in Raptor Lake, my job mainly was to, first of all, align with the expectations in the performance core, which is where I worked on. We were trying to kind of get the learnings from Alder Lake, the previous client, and apply those learnings, like trying to get more performance for Raptor Lake.
Most of my work is focusing on definition and bringing new innovation to the core, new features, and we're working with the design team and making things happen.
I would say that we spent up to 3x times total in terms of design and debug for all the post-silicon learnings which we took not just from Raptor Lake but also from the Alder Lake, because the Raptor Lake architecture is based on the Alder Lake architecture.
Overall, I think it's a combination of the features improvements in terms of the number of core and atoms, and also the caches, and overall memory frequency and the IP improvements in terms of frequency. So all this combination gives us an improvement in terms of performance while the architecture being the same.
What were the changes like inside the cores?
We saw that even in the client space on desktops, we want to have bigger L2 and L3 cache sizes. And that's one of the big changes which was added in Raptor Lake, which is actually seeing the big boost that you get on both the single thread and multi-thread performance. I think hybrid architecture kind of gives you the benefit of best of both worlds. You have P cores which deliver unparalleled ST performance, and when you want to run empty workloads or multi-threaded cases where you're actually not performing a very high intensive workload, there you want to really have an efficient core where it doesn't consume so much of your battery life, or in the desktop also to kind of save energy there.
So the hybrid architecture actually is going to continue, and it is the future, because it is actually giving us a balance between the big cores and the small cores, and we can actually configure them using the software technology.
And also one more thing that was important was to keep it backward compatible with Alder Lake. So actually we squeezed all this additional goodness within the same package as Alder Lake has, which is very important, because what you can do is you can either take Raptor Lake and put it in an Alder Lake platform, or you can take Raptor Lake and put it in the dedicated Raptor Lake platform with the improved ingredients on the platform and get even more.
In Raptor Cove, we had a new capability, a machine learning based firmware, that what it do, it looked at the core behavior and dynamically optimize and configure the core to give a better performance. In the machine learning part, okay, we are looking at the state of the core, and we are looking at the state of the fabric, the ring bus, and then by that we understand the memory traffic, how busy it is, do we have a bandwidth on the ring, and use that for example, prefetcher aggressiveness. That's the thing we're doing. That's machine learning example that we recognize.
What was one of the biggest challenges you kind of run into when designing Raptor Lake?
The one and obvious, of course, is what all of us during the past few years is the COVID. And actually, the majority of the design cycle of the Raptor Lake was during the COVID. And of course, since we're working in all the geographies, and there were a lot of people that actually engaged and worked in this project, and which we never saw each other. Yeah. Usually we used to travel and meet people and see and review and etc. And this actually didn't happen at all.
We always wish to improve ourselves and of course the project and and the SoC and the performance and the power. So the main challenge was to keep the balance between the performance and the power.
So when we are talking about Raptor Lake, we are talking about the higher frequencies. And at such a high frequencies, the thermal aspects play a really important role, and we can't just neglect. So the accurate evaluation of the thermal hotspots from the performance score is the first process, and we ensure that we take appropriate design thermal action so that those thermal hotspots are not limiting us to push the performance and the frequency of the core.
Frequencies is very important, memory cache increase, and the last one, of course, is the new IPC feature that we gave the machine learning. I think it's a breakthrough. It's something new that we did, and I think that will give us looking forward. That will be a big breakthrough that we can continue improving and give us a lot of benefit.
Of course, it's important to understand it's achieving higher number of cores within the same power envelope, and also achieving a higher core frequency, again, without breaching this those limitations that we are currently familiar with.
Can you tell us a little bit more about functional validation, also all the different things that you do?
Functional validation means a lot. I mean, it's a very long life cycle that starts 1 year before silicon arrives to the lab, and it lasts at least 1 year after the silicon arrives to the lab.
We have 1 year of testing before the CPU is going out to the market. And inside this year, it's very crazy time, and we're releasing a test program once in 2 weeks. Also, we have a validation cycle. That means working with different stakeholders to check like in system and correlate the results that we got.
So basically my main role is coming at post-silicon, at the backend, meaning after the design has finished the design, and then the fab manufacture the first articles. We actually get them, test them, and then characterize them even prior to power on.
What kind of testing, can you give us a little bit of an idea of what's the testing that you do before you hand it over to the guys to do the power on?
So we need to test for a few things, but most important, first of all, it's to test that we don't have defects, because just giving defects first to the power on and of course later on to the customers, it's not something you would like to do. This is the first part. On the other hand, you also need to characterize the part to see on what conditions it best perform.
There are times you do some kind of an optimization, you think you nailed it, then you take it to a general workload, and you see that it hurts something else and you cannot take it. So it happens. We usually find a way to make it happen or to mitigate or work around it, but sometimes you need to drop it.
We have PCIe experts, we have memory experts, security experts, virtualization experts, Type-C experts, and the list is very long. And each of them looks at the sets of features that he owns, and every registers that is under his domain, and he start planning, how would I do my work best when the silicon will arrive? What do I need in the silicon that will make sure that I have very good coverage and that I can really deliver the best product to the market?
So for Raptor Lake, what was one of the biggest challenges?
I think that the most challenging things about Raptor Lake is the fact that we did it right after Alder Lake. Because Alder Lake, it really was a great processor with great improvements, architectural and performance, and a lot of good press about it. And then just a year later, you need to do another product that should be even better. On both Alder Lake and Raptor Lake, we have the 8 performance cores, but on the Raptor Lake, we added additional 8 efficiency cores.
So one of the main challenges in Raptor Lake was the additional E-cores. The additional cores consume more power that needs to be taken into account, and it requires slight tuning and different optimizations versus the product that we had previously. So we need to find the balance between the drop in frequency, the additional performance we get from the cores, to make sure that we have significant gain over the previous product.
So one of the major challenge what we had is, so the memory validation, as you know, right, it's one of the global component of the SoC which is being used across all the domains, and making it enable to the higher frequency with the high speed cores as well as all the components sitting on the SoC. Getting it enabled was really a challenging task, and it was a multiple geos were involved.
I mean, I think that one of the biggest challenge is that we want to support all type of DIMMs and all type of vendors. I mean, all part numbers that exist in the market, and then we need to make sure that whenever we manage to get to stable frequency, it keeps stable with every type of memory DIMM in the market, every vendor, and
not just one or two, like all the possible vendors. So working with vendors is also a big monumental task to make sure that.
And it's almost endless.
You guys learn a lot from Alder Lake. What were those learnings that were carried over to Raptor Lake?
In the validation area, we learned how to work, how to debug, how to integrate into the test program, a lot of learnings. And like I said before, we moved to new tools, new environment in Raptor Lake. So all the learnings come from Alder Lake, what we really need for the validation cycle, and I think Raptor Lake did it.
So as you know, the entire ecosystem has to lift up. And in the Raptor Lake, we have lifted up the entire ecosystem, not only just the number of cores or the speed of core, but at the same time, the critical interfaces like memory and PCI also has been upgraded to work and get the best out of the cores.
I remember when our production step arrived and we said, at the backend team, hey, let's try to go to 6 gig.
Right off the bat, right?
Let's try. Let's put it in our plans. And to try to get there.
So the first reaction was, no way, we cannot get to 6 gigahertz. But again, our manufacturing and process teams did incredible work. They had significant voltage reductions and silicon parametrics improvements, and they enable us to reach those high frequencies. The top bin in the product stack will be able to hit a single core frequency of 6 gigahertz out of box.
I'm really proud that this is my product and achieve this, but we must improve ourselves from product to product. The market requested it, and I think Intel, by leading this area, this is the call that Intel must do. Yeah.
Tell us a little bit of your experience for working on Raptor Lake.
Yeah, Raptor Lake started as a very interesting project. It's not done from scratch. It's a second generation over the Alder Lake, but still the challenge is to make it a great product with great value. Great value means that the customer, the end user, will see a lot of performance. We would like to have a great experience of gaming, creators, and to be very much competitive.
To create a processor design, it's taking at least a couple of years. So when we are talking, let's say, about Raptor Lake is today, in PRQ.
Exactly.
We are working probably on the project that you will see
in a couple of years in the future. Yeah.
And it's definitely much more progress technology, which is much more challenging as technologies are becoming smaller. 3 nanometer, 5 nanometer, they are becoming much harder. So it requires more expertise from us.
We always have a aggressive plan and what we call a committed plan, high confidence plan, and we make it on the aggressive plan by the week. So it's exactly yearly cadence than the previous project. Workweek 34, this is what we end up internally, the execution, and from projection, it was perfectly done.
What was one of the biggest challenges you guys came across and how you were able to overcome it?
We are working in very multi-site mode. Most of the time we are working a lot with India, but of course there is a collaboration with US, with many sites in US and also with Malaysia. So it's like around the clock.
Yeah, like you guys go to sleep, we'll start. Yeah.
Exactly. Sometimes somebody is going to sleep and then when you're awake in the next morning,
someone will start again.
Yes, a lot of team all around the globe, different culture, different people. You don't know them many times.
How's the logistics for that, like deploying a new tool?
From COVID days, we actually got used much more to interactive work, even with Zoom and video. So most of the time we are presenting our new tools, we are doing a lot of exploration, showing a lot of results to design teams, convincing them why this new solution is better, what it is doing better, and then usually with a cycle of one project, it is being adopted, and then we are moving to next generation features. I think it's a huge achievement for Intel, and definitely, it's generation over generation seeing this improvement and how everybody are talking to us outside of Intel. If I'm talking to someone, outside, oh, you're in Intel, your processors are great, and how do you do that? They're very impressed. So, and feeling a part of it, just saying I'm doing this and that to make it happen is actually...
It's a great source of pride.
Yeah.
Well, folks, there you have it. We had some amazing chats with the engineers. I would like to say thank you to all of them and also to all of the people that were able to make this possible. It was a great experience. I also hope that it was a great experience for you guys and you were able to learn something valuable. And I'll hope to see you guys next time. Thank you. Appreciate it.